This will be a match made in shell. I'm Ray Myers. Welcome to Craft vs. Cruft. And it is 2025, the year of DSLs, domain-specific languages. So, of course, we're going to have to kick off that series with one of the most famous and infamous DSLs that's used in programming. We love it, we hate it, we love to hate it, and we hate to love it. I'm talking, of course, about regular expressions, or regex. Now, I have talked to a lot of people who they hate to use regex, they refuse to use regex, etc. I contend they are quite useful within their scope, and I'm going to get into what that very specific scope that regex makes sense for. But I do kind of get it. They're not very approachable. People like us that look at code for a living, sometimes find the type of code that is embodied in regex to, I guess, look like code looks to people who don't look at code, right? It looks like line noise. Do people still know what line noise is? It looks like random characters. And it's very dense. And I think what's happening here is not a case where it's actually complex, right? It's quite simple, but it is hyper unfamiliar often, right? It is sort of speaking a very simple language, but in an unfamiliar alphabet, and it is very kind of steep to get over that alphabet. So if you haven't used regex or enjoyed it very much to this point, don't tune away. I'm going to try and convince you that actually this is quite simple. And maybe you'll like to use it, maybe you won't. That's just fine. But also, we're going to use that to illustrate some facts about domain-specific languages and how they can be implemented. So first, I'm going to show a simple example of implementing a subset of regex in C, which is from the book Beautiful Code. And I'm then going to implement actually the grammar of regular expressions using Antler. So we'll actually be using one form of parsing tool to implement the syntax of another form. So stay tuned. Now, first let me just show you what regex look like briefly. You've probably seen them. I very much like this website RegExr, and also this newer one, I think, Regular Expressions 101, for trying these out. And you can even say what flavor of regex, depending on what language and context. One of the neat things about regex is it's available in about any programming context that you could possibly be in, right? I might be writing a query for some log engine in Google Cloud, or I might be programming in PHP or Python or Java or whatever. I'm going to have some flavor of regex available to me, even on a command line. So that's nice. However, they all are different flavors, right? So this is a very helpful website, and this will show you, if you're not able to follow a regex, you paste it in here, get a nice explanation. So we'll see that pop up as we go. I put in some examples of just a number. Let's start with a very simple example of, I want to parse a potentially floating point, potentially negative number. So it might be, and this is a character class I'm going to make with these brackets, is what this is called. And I'm going to say 0 through 9. I want to match like one of those. You see we're matching a bunch of things. We want to match this as a group, but we've got to start. Now, 0 through 9 comes up so much that there's a shortcut, /D for decimal, right? So that's fine. And to make one or more decimals match, I'm going to add a plus to that. All right, so now we've got these blocks, and you can see this explanation is coming up. So if you have a regex you don't understand, just paste it in here. It'll tell you all about it. And it might be negative. So we can use a dash here, and it'll match the beginning of it, but now we've lost the ones that don't have a minus sign. So that is optional. I may use the question mark. So you notice we've got the plus that modifies it to say I want one or more of what I just said, and we've got another modifier, question mark, to say I want 0 or 1 of it. And star, as we'll see later, is the other one. Is 0 or more, right? So we have an optional minus sign. we have one or more decimals. So this gets all the case where there's no period. Now, I can't just expect it to work if I do dot, because this is another thing, a symbol that means something in regex. It matches any character, right? So I'm going to use an escape. Okay, so now we've got a decimal, but some of them don't have it. So again, I'm going to use the question mark. And then after that, we've again got a bunch of numbers, right? And really, that whole suffix, I want the dot and all the numbers. I want that whole thing to be optional. So I'm just going to make a group with parens and make that optional. So now in just a few characters, we have defined the pattern of a number that is possibly negative, that possibly includes a decimal component. You'll notice the only thing I've included here that it didn't match is if the thing before the decimal point is not included. And you could decide whether you actually want that to be valid in the pattern you're matching. I don't happen to care for it right now, so we don't need to make the pattern more complicated to accommodate that. And as you can see, you can get the explanation. You can see the matches on this site, and this one's kind of the interesting one. And it's actually gotten the output of this group. So not only can you match a string, but you can pull stuff out of it. And so I probably want all of these. So let me just put this minus in a vacuous group here, and what's before the decimal in a group here, so that I can get everything out of this. Yeah, and so group 1 has got a minus in it, group 2 has got 1444, and group 3 has got 0.143, blah blah blah. So this is really cool, right? Like, in just a few characters, we've written what would, to program correctly, it wouldn't be crazy complicated, but it'd be like a fair amount of code. It's not going to be any one-liner. Now, when is this not good, right? Well, obviously this code gets long, and the code being so dense might become a problem. So just when it's a more elaborate pattern that you want to parse, maybe regex is no longer the tool, or maybe you want regex as part of a larger flow. But also, there's a formal definition of when regexes do and don't apply. The regular in regular expression, right, means this matches regular languages. In this context, a language just refers to a set of possible valid strings. So you can think of it like a pattern. And regular doesn't just mean normal, right? It means there's some sort of formal regularity to it. It has some particular technical meaning. I'm not going to get too far into that, but there is something called the Chomsky Hierarchy. Yes, it's that Chomsky, Noam Chomsky, right? He did stuff that impacted computer science as well. So in this hierarchy, there are regular languages. It's kind of the simplest, and context-free, the one above that. These are the two that you're going to see the most often. So roughly speaking, regular expressions can match any regular language, and context-free languages are matched by context-free grammars. And most programming languages are defined with grammars that are kind of sort of context-free grammars. They're kind of adjacent to that. And indeed, modern regex engines often have little backdoors that will match things that aren't technically regular languages, but it kind of hovers around that. So regex for regular languages, roughly. BNF notation, Bacchus Noir form, for context-free languages, roughly. And that'll get you started. And these correspond to different kinds of automata that's capable of processing these languages. But that's just sort of the computer science origin of this stuff. In reality, you kind of learn what will and won't fit in a regex, and an example of something that won't is match sets of parentheses. You need a more sophisticated parsing technology to do that. So back to this beautiful code book, and this wasn't the first book that code was published in that we're about to look at. They talk about the practice of programming that Brian Kernighan was working on with Rob Pike at the time, who's the one who wrote this code. And Brian was really struck by how good Rob's example. By the way, these are people that worked on Unix originally, right? Very influential programmers. And this is in C, a serviceable implementation of a useful subset of regex. Like, it is so short, right? So if you don't believe already by seeing what we just saw that regex is simple, you can implement like a useful part of it with just this amount of code. Does that not convince you this is a simple thing, right? And this is the part that implements, that you can match any literal character, that you can match just any characters like a wildcard. That's the dot, right? That's the meaning of that. That's why we had to escape it. You can say this must occur at the beginning of the string, and the $, this must occur at the end of the string. Let me blow this up a little for you. And then the 0 or more matcher, the star modifier, right? So that subset, right, is implemented just by this little C code. And if you want to see that adapted into, a pretty serviceable implementation that implements some more regex features, I'll link to this repo where someone has just done a fantastic job of that. But let's take just the code from the book, right? So here we have in a little C compiler the code we just saw. It's reproduced from the book Beautiful Code. And a lot of test patterns here, so we know that we haven't broken it. So that's all nice. And I've added some assertions though at the top here for a feature that I want that we don't have yet. We have the star modifier, but we need the plus modifier as well, I've decided. So, and you can dissect this code in more depth later if you like, but I'm just going to show you. We're going to add the match plus method. Function would be the term in C, not method, I suppose. And so match plus, so what's happening here, right? So from the top level, we're calling match and handling the case of it being at the beginning, or insisting that it's at the beginning, and then we're going to delegate to the main loop until the end of the string. That's the null terminator, end of a string. And in match here, this is handling the different syntax cases, right? So it could be the end, it could be a star, in which case we want to take the thing before it and call match star on it, and then the handler of the $sign syntax. All right, so match plus is kind of like match star, so that's why I copied it. So star again is 0 or more, and it ought to return, I guess, 1 if it successfully matched, and 0 if it did not. That's like a Boolean, false or true, right? And this is going to be 1 or more. Without looking too carefully at what this is intending to do, I can imagine that whatever check we're doing here, we just need to do it at the beginning. So we do need to match. So it's like if we don't match, then I'm going to return 0 up front. We fail. After that, we can not match and pass, but we have to match at least once. And then I'm going to move the check in the loop to the beginning instead of the end, so it's going to become a while loop instead of a do while loop. And I've tried this before, so I have some confidence that I'm doing something reasonable here. So let's try that out. Okay, and yeah, we haven't added the support for it. So if it's plus, then we will call match plus. All right, great. Right, so this is what we're able to do now, is we can say FO plus and it will match just FO. FO plus will also match FOO, but it will not match just F, right? It would if it were FO star, right? That does match, but not FO plus, because there's got to be at least one. So plus means one or more. All right. So that's a little bit of regex implementation, and like I say, there's more in that cool little repo here, tiny Regex C, where they've expanded it so it doesn't just do interpretation real time, but it translates it into a struct. It compiles it technically, right? It's a very simple compiler, and puts it into this structure, so that, and that's going to allow it to support things like those character classes we saw earlier. And by the way, that tiny Regex C is only 500 lines long, and it is featureful enough to implement this common, though slightly incomplete, regex for email addresses. This will match most of the email addresses you'll encounter, though you know, it's not entirely up to spec, so you probably shouldn't use it in production. Now this is getting to the size where in a real production code situation this might get kind of confusing, and I've seen ones certainly far longer than this one, but you'll be happy to know that something you can do is space them out. Like, this is an option that exists in the Python standard library, for example, is this verbose mode, where you can just put in optional spaces and new lines and stuff and give them little comments and say what different parts of them are doing. And there's other ways of approaching that in other, you know, languages and contexts. So yeah, I think that's not a bad idea. I'd like to put a pin in it for today, and next time come back and actually show you what a grammar for this regex syntax looks like. I went ahead and coded it up in Antler, which is a parser generator. And as you can see, it's fairly short, you know, fits in about a screen full at this size here. And so I'll delete this and we'll build it up from scratch next time, and you can see how grammars come together, you know, which is one of the most important tools in making DSLs. So until next time, as Lao Tzu said, with patience, the most tangled cord may be undone, and may all your regex be untangled. Thank you.